You're listening to the Autism Weekly Podcast. Each week, we share community voices and bring light to stories that increase awareness, acceptance, equity, access, and inclusion. If you haven't already, subscribe to join the Autism Weekly family. I'm your host, Jeff Skibitsky. This week, we're joined by Paul Constable, an optometrist and researcher. Paul's journey into autism research began with his son, Miles, who was diagnosed at age 3. Faced with testing challenges, Paul explored retinal signals. Inspired by Ed Ritvo's pioneering work, his dedication led to groundbreaking studies and advanced signal analysis methods. Today, we'll delve into research on utilizing eye signals and AI for quicker and more precise diagnoses of autism in children. Welcome to the podcast, Paul.
Thank you.
So, Paul, one thing I'd love to be able to do is to give our listeners a little bit of a flavor of who you are and what brought your passion to the field. Because a lot of people who get into research, who get into practice around autism, there's a personal experience that led to this. And I'd love to hear your story.
Yeah, it's quite a long story, but it's it all began with, certainly I was living in London, just started the PhD, and I was looking at eye diseases in a completely different field. And our first son was born, Miles, and he was a very sort of quiet boy, and we thought he was, didn't complain very much, but he had this fixation with opening and closing doors and switching lights on and off. And one day the health visitor came round at the age of 2 and said, look, he doesn't really talk very much. And we were like, oh, but he's a boy. Boys are always a bit slow with their, with their language. What do you expect? And she said, no, he really doesn't talk very much. And of course, she sort of suggested we get a referral and send us off to sort of some counselling to try and develop his language and so forth. And, it was true in a sense. He made very little eye contact. He never spoke our name. He referred to us as this one or that one. And so the signs were always there, but we didn't know. Our parents were overseas. We had no grandparents. We had no sort of reference point for what's normal in a child. And so at the age of 2.5, 3, we finally got to see the pediatrician and the psychologist and the assessment. And we walked into the assessment naive and went for a coffee and came back and said, we're going to do some stuff with Miles. And they came back and just said, oh, look, your son has autism. And it sort of hit us very much out of the blue. It wasn't on the radar. We didn't know what autism was, really. We didn't have any understanding of what the future might hold for Miles and what this all meant. And so that then sort of began, I guess, the search for me personally into what is autism and how do we recognize it. And the question I had in my mind was, well, what happens next? Will he ever read? Will he ever sing? Will we ever play football together? Is this the end of the world, so to speak? Everything sort of came crashing down. So I wandered into my PhD supervisor's office in the next week, probably looking a bit glum, and said, oh, look, Jeff, my son that I've shown you the last, photos of the last 2 or 3 years, apparently he's got this thing called autism. And Jeff was 83 at the time. He'd been working in vision science for centuries, it seemed. And he just turned to me and said, well, dear boy, maybe there's something to do with the brain. We must look at the electroretinogram because, he knew that people with sort of cortical or neural problems in the brain also often had sort of signs in the retina. And this was perhaps, patients with Parkinson's disease, they have changes in the retina. And so this was sort of the link. And so he then introduced me to a lady called Dorothy Thompson at Great Ormond Street Hospital in London. And we began, in a sense, trying to record ERGs or electroretinograms, which are the signals from the retina in people with autism. But at that time, back in 2005, to record one of these tests, you needed to put an electrode on the eye. You needed to put drops in the eye to dilate the eyes. This was all very uncomfortable. So it took a while to get ethics, and we could look at sort of adults really only at that stage. And so things sort of stopped there because we had a very small study in sort of 2016. It took us to get everything going in about 12 adults. And we replicated some of the very early findings of a guy called Ed Ritvo, who way back in 1988 did the very first study at UCLA into a population of children, I think in Utah, and discovered some differences in the signals from the retina. And that was the only study that had been done up until that point. It had just been sort of gathering dust in the wilderness, I guess, because no one had been able to do these tests in children since then.
Yeah.
So that was sort of the beginning of the studies into the ERG. It was really, the questions about how do we improve the diagnostic process better for a parent, and just understanding, we sort of left the consulting room, days. Here's a leaflet. Here's a phone number. Here's a phone number to go and call the National Autistic Society, and that sort of led to then, the search for a school. What does it mean? Nursery school, primary school, and we sort of, you realize, I guess, then as a parent that you're on that different journey. The other kids were growing up and getting toilet trained and learning to eat and going out and having parties, and we were sitting at home with Miles. Suddenly the invitations dried up. There was no more invites to the school, to the friends' birthday parties, because Miles was just sort of, his behavior was a little bit different. So I sort of thought that then led to sort of, I guess, a separate area of interest in sort of how do we help these children. And as an optometrist, I was sort of thinking, well, and you might recognize I've got a big prescription. I wear glasses, and I think any parent who wears glasses probably thinks, I must get my son's eyes tested. Maybe they need glasses as well. And I'm the optometrist in the family. I should be able to test my son's eyes. But it was just a very fearful experience, just because I couldn't consider taking my son to somebody who would be able to communicate with him or understand, what his needs would be in the consulting room. And around this time we were looking at schools, and there was a special school, I guess you'd say, in London called Queensmill, and we thought Miles, that was an autism dedicated school. We thought Miles would fit in there, and they came to look at Miles and said, well, he's not bad enough for us. And then we thought, oh, okay, that's probably good in a way. So he sort of ended up in sort of mainstream school, which was good with support. But when I visited this school in Queensmill in London, it was sort of the children there would have had 2-to-1 carers and were very non-verbal. Miles was quite non-verbal. I think he started to speak when he was about the age of 8 and got out of nappies about then as well, and started to develop some skills then. So he was always about 5 or 6 years behind the pack, but not as bad perhaps as these children that were in this school full time. And so I began doing eye tests on these children, and then started developing strategies for testing children with poor communication, because that came about because I finally took Miles in for an eye test at the age of 8 or 9 or so to the optometry clinics at the university where I sort of worked, and thought I had some colleagues there who'd be able to sort of manage the eye test quite well, but they were terrible. It was just a complete disaster. They were just a complete disaster. Miles would want to go up and down in the chair and wouldn't sit still. Put the glasses on, and they wanted to put the drops in his eyes, and they put the drops in his eyes, and I was like, don't put the drops in his eyes, don't put the drops in his eyes, no. And so of course he's got the drops in his eyes, he can't see, and we're on the 19 bus going home, and of course he's full of tears because he can't understand where his vision's gone. He's sort of crying out. He likes to count the numbers down on the bus as we go home, and he knows, and he can't see the numbers, and he's just a mess. And I realized then, as a parent, it's like this has got to change. So I started working in sort of trying to sort of educate optometrists as well about how to approach a child with ASD in the consulting room, and did some guidelines and stuff like that. So that was I guess the early years, and there was a lot of support I had, I think, from a guy called David Bowler, who was at the university where I was working. He had an autism research lab, and I went to see Dermot and said, look, my son's got autism, what does it mean? And he was working in adults, and he was really a bit of a godsend, because he said, look, Paul, things get better. It's every phase of life is hard. It's going to be hard in their preschool years, and then they'll get to teenage years, and then they'll get to adulthood, and they're all going to bring different challenges. And you just need to have hope, but work on language communication, which we did. And it gave a bit of a ray of sunshine, I think, because at the time we were pretty down.
Well, you went through, it just to kind of go back a step. With Miles went through the typical diagnostic process, it sounds like. And what you're looking at is groundbreaking in the fact that you're hoping to bring different information, more information to the table. So what is it that that maybe a family is going to learn, or a clinician may learn by utilizing eye signals or AI through the diagnostic process that's different than the psychological diagnostic assessment or neuropsych assessment?
Yeah, well, I think the big question I had as a parent was like, well, how bad is it, and what's the future? So it's this prognostic. It's a biological marker, like it's a physiological thing. It's not. Oh, his language is on a 2 out of 5 scale, or his social reciprocation score is this score or that score. It's very abstract, and although the ADOS is very good, it's a standardized test, it does give normalized data. But as a parent, maybe it's maybe my scientific background, but I wanted a number. I wanted to know the cause or the reason. It's not like perhaps diabetes or hypertension or something which you can measure and sort of monitor, and so that was sort of, I think, the attraction perhaps of an objective test that taps into the retina, which is connected to the brain, which we know in other conditions which affects the brain, has different signaling properties, and we thought that those different properties would help us to categorize better or give some sort of indication as to what chemical may be imbalanced in this particular individual, and give some sort of, and gives, I guess that's sort of the question you have is, what causes autism? Why does my son have or daughter have autism? What's the biology behind this condition? And of course, the genetics is all out there. There's no answer to what causes autism, and I think that was sort of part of the question for me, is like, well, what's the main driver for Mars's behavior? Is it too much of this or not enough of this, or which pathway is affected, in a sense? And that's, I think, where the ERG may help to give some assurance to parents as well. It's like, it's not their fault. I think that's sort of the question we all have is like, why me? Why us? What did we do wrong? What's happened? Whereas if there's perhaps, it's because of there's a little bit too much of this, or a little bit less of that, then it perhaps makes the condition perhaps more understandable for a parent. It's like, it's not you that's causing this, it's their biology in a sense, or their physiology.
And that makes a lot of sense. I mean, just looking at what you're describing there, it's giving more of a medical understanding to, this is the causality. Are you also potentially looking at, or is there future research that's looking at, maybe there's some treatment ramifications that are coming, or maybe a clinician would look at putting more effort into these sorts of skill building or into this sort of medication path because they're seeing this through the ERG?
Yeah, that was really the goal, that this would help with the management and diagnostic, sort of categorization. Perhaps, there are, looking at the genetic studies now, there seem to be lots of different flavors of autism, lots of, based on pathways and immune pathways, and which I get lost in as well. And maybe this sort of, the ERG can help sort of at least help to clarify some of those categorizations. So look, this group of children are really going to benefit from this medication, or this group of children don't even touch medication, it's not going to help you. Or this group of children are going to get a bit better because it's actually the retinal signals look pretty normal, and there's a good prognosis, or there's a retinal signals are really bad, and maybe we need to put more effort into the communication, really. So give you more support, those sort of things.
That makes, just it gives hope to being able to say, we can focus our care better, and that we can hopefully expedite our care models to be able to be more efficient in what we're trying to be able to do to empower the kids or the adults.
And I think it's also, I guess it also gives that sort of marker that you can measure, like blood pressure. Are things getting better by doing this? Are things changing in the balance of the neurotransmitters in the brain? Perhaps are they having some effects that we can detect in the retina quite easily without doing a brain scan or an EEG or those sort of things. So that's perhaps the attraction, the party attraction to doing this sort of study.
So if we start at the very beginning and kind of work our way forward and look at the diagnostic process alone, Is this something that you're looking at diagnostics could potentially start earlier? Or, I mean, is this something that it still would be, we're looking at 18 months as the starting point? And what's the start? Where do we start with the
Yeah, that's the idea. I mean, I guess, I dream one day. Many children, you have the neonatal screening where they do the hearing test, and it'd be great to do the eye test as well, the eye screen as well, and say, oh, look, the hearing is good, but the retina is also good, and or whatever. And so that would be the idea. And in theory, it's possible. We haven't got to those younger children yet. That's for future studies. But in theory, you can record an ERG in very young children when they're sleeping or when they're breastfeeding or so forth. And that's where I think, once they get to the age of 2, 3, 4, 5, they're a little bit harder to test. So it's sort of looking at that. So at the neonatal age would be the pathway, and bringing it in as part of that neuro screen, I guess, for all children, along with a hearing screen. You do an eye screen, you do an ERG, you do an auditory test as well. And I think that would be the that's what we're hoping to get to.
And I mean, you had mentioned that there were ethical concerns back in the 80s about this, but I mean, to calm people's fears, I mean, a lot of those things have been solved for. And
it's now a lot easier to do the test. I mean, I guess we had to wait for the technological advances. A company called LKC Technologies, based in the US, developed a handheld device called the Retina, which uses a sticker electrode on the cheek, which means that, and you don't need to use eye drops, so it measures the pupil diameter, so we don't need to dilate the pupil. So no drops, nothing on the eye, portable, do it in your office, do it in anywhere you like, not a very invasive, and that really enabled us then to do the further studies with the children. And it was really Ed's help in the end who sort of really helped, because I'd met Ed at IMFA once in Boston, although I don't think he recognized me, but I was sort of like in awe of Ed Ritvo. And we published the adult study, and I thought, oh, look, let me send this off to, I couldn't find Ed's email address because he'd retired. And so I think I sent it to an Ari Ritvo, which I assume might have been his daughter, but I think it turned out to be his ex-wife or something anyway. But she was at Yale. And I sent this paper off to Ari and said, oh, you might be related with Mr. Ritvo, you might be interested in this study that we just sort of replicated. And I heard nothing. And at that stage, we moved back to Australia, because I sort of had a job here in Australia, left the UK. And I was sitting at my desk one day, and I got this phone call, and it was like, hey, Paul, it's Ritvo here. How are you? It's like, oh, Ed, how are you? He said, yeah, man, I got your paper. Really cool stuff. Look, I've got some money at UCLA. Let's do a study. And, Ed's 88 at this stage. But I'm like, yeah, Ed, let's do the study. So it sort of gave him a lot of, he really drove the next phase of the study. And I think it was part of it was nice for him to see some of the culmination of his early work sort of being replicated and repeated and expanded. And that was always his dream. He was quite a visionary guy to sort of say, we want to use this ERG to help diagnose and to understand autism more. And so from 1988 to 2016, there was just this dead space. If you look at PubMed, there's no publications in the field. We started, and then we started to get stuff going. And so I sort of feel a little bit carrying on the baton from Ed's pioneering work to try and sort of answer those questions. That sort of drives some of the research as well. And so moving on now, we've really expanded the potential of the electroretinogram. And so I guess, to put simply, what we've been doing, I guess if you think of the electroretinogram a bit like the electrocardiogram, it's like it measures the electrical signals of the eye rather than the heart. So I guess it's the heartbeat of the eye, if you like, you could say. And we have, when we look at the ERG on a very simple level, you could say, well, you categorize ERGs based on if you think of like a bit of like a song, is it sort of R&B, or is it classical, or is it jazz, or whatever? And they're very sort of broad groups that you can put things into. And when we just do those sort of very broad categorizations, looking at the peaks and the troughs of the signal, we can sort of classify the groups quite well. But it's when you go into sort of the analysis of the signal, what are the frequencies? What's the high frequency? What's the low frequency? What's the beat? What's the rhythm? What's the tempo? And that's really what we're doing with the signal analysis. We're sort of really pulling apart the song, if you like, the signal from the retina, and looking at the structure, if you like, and that's where the excitement, I guess, is coming from. Now we can start to really sort of untangle very small changes in the signal in these children with ASD or children with ADHD. And then, the third group, when we were doing the study with Ed, we were recruiting children with ASD, and of course, but some of the children would turn up and they'd have ASD. Oh, and they've also got a bit of ADHD as well. The parent would say, oh, well, don't worry about that. I'm sure it won't have any effect. And I remember it, at the time when I was diagnosed, he's got ASD, but there's a little bit of ADHD in there. I'm like, well, what's this ADHD stuff? I don't know. Great, he's got a bit of ADHD as well. Anyway, but we started to notice that these children with this little bit of ADHD, this other thing, they were behaving quite differently to the children just with the ASD diagnosis. And so we thought, oh, well, maybe there's something in the ADHD group as well. We hadn't really thought about that. So now we looked a little bit at children just with ADHD, and then COVID came and we sort of stopped. But we found out the children with ADHD had a very altered signal to the children with ASD, and the children with ASD plus ADHD, they were somewhere in between. So it was sort of this sort of spectrum of signals that we were finding in these three populations. And so the question, what we're looking at now is children with ASD plus that little bit of ADHD, and children with the ADHD diagnosis to try and sort of see if we can, which we think we can, sort of pass out these three groups. And that's where the AI comes in, to help us with deciding which signal characteristic belongs to which group. And so sort of combining that sort of the AI plus that deeper signal analysis, looking at the tempo and the frequencies and stuff that we can do in the waveforms, building that into a computer program, into a testing tool for a clinician that can say, do the test, ping, here's the likelihood of the probability of your child being in this group and how severe, going back to that severity, where do they fall in this pool of data that we have, what does it mean to the parent, and how then, what might be the best way to manage that. And so we're sort of pushing, again, with the University of Connecticut, with Hugo's group there, that with bioengineering, we're sort of pushing now to develop a new device, if you like, which will run off a smartphone, which will do all the calculations, so that the smartphone will run the device, which is sort of like a pair of glasses, which will measure the signal, and then the clinician or the parent or the psychologist or the school teacher or the nurse or kindergarten teacher, anybody can sort of do this sort of test, and the parent perhaps could do that at home and sort of monitor things as well. So that's yeah.
I mean,
so it's
the value of this just sounds astounding. I mean, and just to have that much information and to be able to continuously build upon it, because it sounds like once you start storing this data, is that now you have computer learning. You can start answering more and more questions through it, because it sounds like the AI is capturing a lot more information than what we're able to extract right now. Is it a matter of we need more participants to be able to kind of build a larger database? Is it a matter of we need somebody to take this sort of technology to market, to be able to bring it to clinicians, to hospitals, to where's the block?
Yeah, well, they're the next steps. I don't think they're blocks, but where we would love to have someone to come along and help. We're building a prototype. We'll have a prototype to test in sort of middle of the year or so, and so then it's a case of then looking at industry, our partners, and trying to sort of develop it and get a patent and produce it, and then get a large clinical, multi-center clinical trial, because that's always the thing. Is like, well, populations are all different. The diagnostic standards, although they're similar or very standardized, there's perhaps some variation. I guess the other important and new thing that I've been working on with a group in Germany at Siemens, AI, the media about how AI is destroying the world or whatever, but I think I see it as really sort of positive and useful thing. And some colleagues in Germany, they've been sort of generating fake ERG signals. So based on the population signals, the ERGs that we have, they can use AI to synthetically, I guess it's deep fake making. They've just started sort of showing me some of the data, and I can't tell the difference between a fake ERG from an autistic kid from a real one. So, we can generate more data to use in analysis based on real data, and so there's a potential to sort of to push AI even further and to increase our sample through the generation of synthetic or artificial signals as well. But it's obviously not. Nothing beats a real clinical population. But it's sort of. It helps the machine learning. It helps the computer understand. It's like, well, you have 2,000 signals. We can give you 2,500.
Mm-hmm. And when you're talking to a parent, because you went through this process, you didn't have any of this opportunity when you went through it with Miles, but talking to a parent, talking to a clinician, talking to researchers, I would imagine it's different stories. And I'd like to hear kind of where the benefit is for each of these populations so that they can be on board with understanding how they can contribute. So when you're talking to parents who are trying to figure out, why is it that this would be where I would want to put my time, energy, and resources. What is the story that they need to hear to be able to understand? This is worth my efforts.
Yeah, I think it's the question of why and what's going to happen. I sort of look at Miles now. I look back to what he was like in his early years, and now he's on his Xbox and he talks a bit. He's still very at home, but the one thing I remember from a woman called Gillian Baird, because we were being a doubting Thomas parent, I got a second opinion from Gillian Baird, who was sort of an expert in autism, and she great advice to me was don't ever underestimate him, and I think that's probably sort of what I took home. And even though things look bad now, you don't underestimate their potential or his potential or what's going to happen, what they can become. And I think the ERG is going to help perhaps to give some certainty to that there is potential here. I think that there is a cause and an effect, and we can monitor and we can program and we can see how this will change in the future. And I think for parents, the other important thing I think is for parents, there's so many parents I saw obviously have come in with one child and then they get diagnosed at 3 or 4 months and then have another child and then the second child has autism, and it's not too late, but it's like, so it would be nice, I think, to have a parent, if they have a newborn child or a younger child, a second one to have, you have one with autism, or is a second one kind of clear or not clear or whatever, and so that would sort of have perhaps help. So interventions can be brought earlier to perhaps the second or third child in the family as well. So that's sort of another aspect to the testing, not only for the child that might be affected.
Absolutely. I think for a lot of parents, it's just understanding creates, a compassion, intention. It creates some of that idea of, this is just part of a journey, but I now understand my journey. Yeah. How about for the clinician? I mean, you look at precision medicine right now, really taking a path. And when you were talking about ADHD versus autism and maybe even creating a differentiation through some of this understanding, is that it probably has something to do with some of the psychopharmaceutical direction that you might have with some of this. Is there benefits that maybe researcher physicians would be looking at saying, I should probably be supporting or investing more into something like this because this is going to lead to some really wonderful results in the future for me?
Yeah, well, it certainly may help with drug targeting, I guess, because we can sort of, the retina is I guess you could think of the retina as a very simplified model of the brain. It has neurons, it has the same chemical signals, and from the pattern of the ERG, we can sort of tell which chemicals aren't working or imbalanced, if you like, and so that gives a target for the medication, and also perhaps for the dosing as well. So say, well, how much drug should I be using? Well, okay, do the ERG, is the signal normalizing, stabilizing? Do you need more? Do you need less? Those sort of things would sort of help. I think they work with the management, I guess, that therapeutic management, and for parents to say, well, am I doing too much? Am I not doing enough? what do I, because medication is always sort of the question I guess parents need to ask. It's like, is this good for my child, or what are the long-term effects? And those sort of questions. And I think just having the ERG in your pocket, I call it, the smartphone in your pocket that you can just pull out and show the parents, say, look, here's a normal signal. Here's your child. They're clearly different. There is a problem. And I think that perhaps again for parents who may be confused or doubt the diagnosis, and I think perhaps it wasn't necessarily in our case, but I can imagine, perhaps parents, blaming the other one, perhaps, but it's actually no one's fault. It's that sort of it's fault free. It's like it is just the way it is, But this is a biology. It's not anyone's or anything you've done that's caused this outcome. You just got to, you're on a different journey.
Yeah. And that makes, it makes it so that you can almost take that next step and start kind of that continuity onto the journey as you described a lot easier versus being stuck in that, where do I go, and almost going in this circular path of I'm gonna hover here until I have certainty, and that leaves me not really understanding, what's going to help make my life better or help empower my child to feel more comfortable or to be able to engage in more of what they're hoping to be able to accomplish in their lives. And I think that's important.
I think that acceptance is the important step. That's sort of like because we didn't understand why. What is it? What does it mean? Again, what does it mean? What's going to happen? What's causing this difference? Why us? But I think having that sort of, and so for us having a biological marker, something that you could sort of look at and go, okay, I see there's a difference. I understand now why things are the way they are a little bit. I don't like it necessarily, but I understand it.
No, absolutely. So where can people follow along with what's coming out in this technology? What resources are available? How I can learn more and dive deeper into what this actually means? Because we're on a 30-minute podcast, is that we're not going to everything that could be describing all the benefits. Where can people turn?
Yeah, well, we're just setting up a website now called retinalbiomarkers.com, and that should be live in the next day or two. And so people could subscribe to the website and leave their details, and we'll sort of send updates to anybody that's interested in, following our work. And if we get research projects going in the US and Australia, the UK, Europe, they're our sort of main sites. Then, we'd love to have everybody involved with developing things further and helping the lives of not only the children, but also the parents. I think parents, families, the whole, and it's not just the parents, it's the grandparents, it's the cousin, it's the whole, everyone's involved once the child has the diagnosis to support that child. So we want to get everybody involved if we can.
Well, thank you so much for giving us some of your time today, Paul, and for the work and passion that you have, because you took something that basically stopped in the research field. Like you said, there's a black hole. And you rejuvenated it. And now it has this momentum where it's going to empower so many people in the future. And I encourage folks to read more about it, invest some of their time and resources to really understand and hopefully be able to build upon the technology that's out there.
Yep. Thank you so much. I'm glad to share it.
Thank you for listening to Autism Weekly. We hope you tune back in next week to learn more about autism in the real world. Autism Weekly is now found on all the major listening apps, including Apple Podcasts, Google Podcasts, Stitcher, Spotify, Amazon Music, and more. Subscribe to be notified when we post a new podcast. Autism Weekly is produced by ABS Kids. ABS Kids is proud to provide diagnostic assessments and ABA therapy to children with developmental delays like autism spectrum disorder. You can learn more about ABS Kids and the Autism Weekly podcast by visiting abskids.com. Thanks for tuning in. See you again next week.